1 diamond, 2 diamonds, goes to an O. Point the diamond down there. And just F's and CL's coming off it. No big deal at all, huh? So they are purple. Three F's right here. So let's get the first CL. So this would be bigger. See this again, we can draw it to scale. It's a CL. This is an F, so not too big a square. Over here, F, and just has 2, but see they don't write the structure with the H's in there, so that's why we're learning this. Learn to draw it for yourself and you'll never be wrong. Sounds like the wind blowing, huh? So that's a CL, these are F's, so they should probably be different color purples, right? So look, that's nothing now. There's a whole kind of ether thing in there, so you color that all the way. And if you want your aliens, draw them now. Let's see, markers don't work, so we want our colored pencils. Got 1 alien, 2 aliens. These guys all got aliens on the side, right? So see, these things would love water, wouldn't they? CL's. So that CL will just take an electron and dissolve, fall off into water. So what are we missing? We're missing an H over here. And looks like an H over here. So the different purples then we were talking about. So we'll do F's are purple. CL should be a little greenish, right? Because chlorine is greenish. Let's see, we've got and 1s I think were brown, aren't they? So see, to a chemist, when you draw a molecule like this one, there's more electron pair action going on than what the classical structure shows. It just shows elements. Well, you got to think these are the elements with the electron pairs. Look at that. I think people call it meth, but it's metheptane. So don't let the words confuse you. Oh, let's see. We just got some hydrocarbons here. 1, 2, 3, 4, 5, 6 diamonds to a nitrogen. So just draw 6 diamonds. 1, 2, 3. I think a nitrogen is top, so we'll count backwards. 1, 2, 3, 4, 5, 6. So 6, 5, 4, 3, 2, 1, 2, a nitrogen. See, I messed up before. Nitrogen's supposed to be that right angle. I'm still drawing it as a triangle. And that'll have a methyl off it, so just use this as a vaso constrictor. Get your blood vessel's shrinking, tightening up. Hopefully it'll cure a migraine. So it's methyl CH3, got a 1 on the end. Come across here, CH2s. Doing these out of order because I'm really in a hurry here so you don't get bored. Counting across here now. I see a methyl on number 2, on number 5 here actually. So here's a methyl. Draw the H's in there if you want. And then there's a double bond there also. So we're not afraid of that. Oh, the highlighters had it. So that makes 5 into a Schroeder diamond there, huh? Five's got all its bonds. Well, that's cool. If you draw it with the pencil, see it shows up kind of reversed. There's a methyl again here, so see lots of methyls hanging off the end. Real easy to spot. Methyls, what do we decide, are purplish? Oh, and this blueprint paper is really nice for crayons. Oh, they're just smooth as can be. And here's a methyl. So methyls are done. We're going to do our hydrogens. We got a 1 because of the double bond. Then we got 2s. Just straight hydrocarbons. It'll look neat. Okay, so 1s are brown. Twos were the scarlet red, I believe, right? It's supposed to be scarlet, but they're kind of pink. Again, these are advanced colors here. If you're not used to the coloring, go back to the beginning because we know carbons are diamonds, so even though they're red, we're not getting it confused with any other element. We know if it's a diamond, it's a carbon. We're just talking about the side groups on it. So there's a IsoHeptane. So hept is 7. Do we get this right? Is that the total number? 1, 2, 3, 4, 5, 6. Oh, see, there's a methyl coming down there. That's where I messed up. That makes the chain into 7. So I picked the numbering wrong. So hept is 7. And I only counted 6. So now when I look at the original up here, that 1 going down is enough to give it a number 7. So I'm messing the color structure up, but better we caught ourselves because that should have been brown too. We'll see if we can fix that one. Kind of late now. What we can do is make the hydrogens purple. How about that? So there's 1, 2, 3. So now if you count it across, 1, 2, 3, 4, 5, 6, 7. See, if I would have just numbered them, because 1, 2, the double bond, I guess would give it a precedence. They wouldn't, unless they call that a number. You pick the most significant side group that's nearest to where you start counting. So a nitrogen as opposed to a double bond, my memory escapes me.